Imagine a day in the heartland. The sun shines brightly, a gentle breeze rustles the leaves, all seems calm and peaceful. But high above, a dramatic transformation is about to unfold. The sky darkens. Towering clouds gather, their shapes shifting ominously. This is no ordinary storm brewing, it's the birthplace of a super tornado. Not all storms spawn tornadoes. These swirling vortices of destruction originate from a specific type of thunderstorm, the supercell. Supercells are characterized by their intense updraft, a powerful column of rising air. This updraft acts like a giant engine, fueling the storm's rotation and intensity. Imagine a giant invisible chimney in the sky. Warm, moist air is drawn upwards with incredible force. This creates a vacuum effect, pulling in more air from the surrounding environment. As the warm air rises, it cools and condenses, forming the towering thunderclouds we recognize as a storm. The key ingredient in this volatile mix is the collision of air masses with drastically different temperatures and humidity levels. When these air masses meet, they create a battleground in the sky, a place where the forces of nature clash in a dramatic display. This collision is not just a simple meeting, it is a complex interaction that can lead to some of the most severe weather events we experience. Warm, moist air, often carried from the Gulf of Mexico, collides with cold, dry air descending from the north. This warm air is laden with moisture, making it buoyant and ready to rise. In contrast, the cold air is dense and heavy, pushing downwards. When these two air masses meet, the warm air is forced to rise over the cold air, creating a dynamic and unstable atmosphere. This clash of air masses creates instability in the atmosphere. The rising warm air cools as it ascends, and the moisture it carries condenses into clouds. These clouds can grow rapidly, towering into the sky as they form the building blocks of powerful storms. The instability in the atmosphere is a key factor in the development of severe weather, including thunderstorms, hail, and even tornadoes. Picture a dance of opposing forces. The warm air rises and swirls, while the cold air pushes and shoves. This dance is a delicate balance of energy and motion, with each air mass trying to dominate the other. The result is a turbulent and often violent interaction that can lead to dramatic weather events. The warm, moist air, being lighter, is forced upwards by the denser, colder air. As it rises, it cools and the moisture condenses into clouds. This process releases latent heat, which further fuels the upward motion of the air. The rising air creates a low-pressure area at the surface, drawing in more warm, moist air and continuing the cycle. This upward movement fuels the supercell's powerful updraft, further intensifying the storm. Supercells are a type of thunderstorm characterized by a rotating updraft known as a mesocyclone. These storms are capable of producing severe weather, including large hail, damaging winds, and tornadoes. The strength of the updraft is a critical factor in the development and intensity of these storms. The greater the temperature difference, the more powerful the updraft, and the greater the potential for a tornado to form. Tornadoes are one of the most destructive forces in nature, capable of causing widespread damage and loss of life. Understanding the conditions that lead to their formation is crucial for predicting and preparing for these events. The interaction of warm and cold air masses is a key factor in this process, creating the instability and energy needed to fuel these powerful storms. As the updraft strengthens, it begins to rotate. This rotation is caused by wind shear, a change in wind speed and direction at different altitudes. Imagine a spinning top being whipped into a frenzy by winds blowing from all directions. This rotating updraft is called a mesocyclone. It's the heart of the supercell, the engine that drives the tornado's formation. The mesocyclone can stretch for miles across the sky, its powerful winds whipping around a central point. It's within this swirling vortex that the tornado will eventually take shape. Section 5. Touchdown. From cloud to ground, a tornado is born. Tornadoes are one of nature's most awe-inspiring and destructive phenomena. They begin their life cycle high up in the atmosphere, within powerful thunderstorms known as supercells. These storms are characterized by their rotating updrafts called mesocyclones, which are the breeding grounds for tornadoes. The mesocyclone's rotation intensifies, becoming a tight spinning column of air. This rotation is crucial for the development of a tornado. The mesocyclone forms when wind speeds and directions change with height, creating a horizontal spinning effect. As the storm's updraft tilts this spinning air into a vertical position, the mesocyclone is born. As this column stretches downwards, it draws in more warm air from below and colder air from above. The warm, moist air rises and cools, while the cooler, drier air descends. This interaction between different air masses creates a powerful energy exchange, further intensifying the rotation. The process is a delicate balance of atmospheric dynamics, where the storm structure and the surrounding environment play critical roles. This further fuels the rotation, causing the column to spin faster and faster, eventually extending all the way to the ground. The funnel cloud, which is the visible part of the tornado, begins to form as the air pressure drops and the air cools rapidly. This cooling causes water vapor to condense into droplets, making the funnel cloud visible. The moment the rotating column of air touches the ground, a tornado is born. This is known as the touchdown, and it marks the beginning of the tornado's life on the ground. The tornado can cause significant damage, depending on its strength, size, and duration. It can uproot trees, destroy buildings, and toss vehicles like toys. This visible funnel cloud, often described as a tail, is actually made up of water droplets condensing from the rapidly cooling air. The funnel cloud is a clear indicator of the tornado's presence and its potential for destruction. The condensation process is a result of the low pressure within the tornado, which causes the air to cool and the water vapor to condense. It's a terrifying spectacle, a testament to the raw power of nature. Tornadoes remind us of the incredible forces at play in our atmosphere and the importance of understanding and respecting these natural phenomena. They are a stark reminder of the delicate balance of our planet's weather systems and the need for continued research and preparedness to mitigate their impact on human life and property. Section 6. Superstorms, when nature unleashes its full might. While all tornadoes are born from the same basic ingredients, some become monsters. These monstrous tornadoes are not just random occurrences, they are the result of a perfect combination of atmospheric conditions. Super tornadoes, the most powerful and destructive of their kind, form under specific conditions. These conditions are rare, but when they align, the results can be catastrophic. These include exceptionally strong updrafts, which are upward currents of air that can reach speeds of over 100 miles per hour. Extreme wind shear, which is the change in wind speed and direction with height, and a plentiful supply of warm, moist air. This warm, moist air acts as the fuel for the storm, providing the energy needed to sustain and intensify it. Imagine a perfect storm where all the ingredients for tornado formation are amplified. The atmosphere becomes a volatile mix, ready to unleash its fury at any moment. The result is a super tornado, capable of leveling entire towns and leaving a path of destruction miles wide. These tornadoes can have wind speeds exceeding 300 miles per hour, making them some of the most powerful forces on Earth. These are the storms that make headlines, capturing the attention of the world with their sheer power and the devastation they leave behind. The aftermath of a super tornado is a stark reminder of the awesome power of the natural world. Entire communities can be wiped off the map and the landscape can be forever altered. These storms serve as a humbling reminder of our place in the natural order and the incredible forces that shape our planet. Section 7. Knowledge is power. Understanding tornadoes for safety. Tornadoes, especially super tornadoes, are a force to be reckoned with. But understanding their formation is the first step towards staying safe. By recognizing the signs of a supercell thunderstorm, such as its rotating updraft and wall cloud, we can take shelter and protect ourselves. Weather forecasting plays a crucial role in mitigating the risks posed by tornadoes. Meteorologists use sophisticated radar systems and computer models to track supercells and issue timely warnings. By staying informed and heeding these warnings, we can greatly reduce the risk of injury or loss of life. Section 8. Stay tuned. The journey continues. Our journey into the heart of a super tornado has just begun. In our next exploration, we'll delve deeper into the science behind these awe-inspiring phenomena. We'll examine the different types of tornadoes, the damage they can inflict, and the latest advancements in tornado forecasting and warning systems. Stay tuned for more insights into these powerful forces of nature. By understanding tornadoes, we can better appreciate their power and take steps to stay safe when they strike.